Dr. Kim SeongJin from LG Electronics. He is serving as a Senior Vice President of Next Generation Telecom Lab, leading 60 research. So his presentation topic is 60 Tera-Mobile Broadband communications for connected AI service and applications. So Dr. Kim, please.
Thank you for your good introduction. I'm SeongJin Kim from LG Electronics. My nickname is also James. While I was in the US and I was participating in standard meeting, I'm using my nickname. Okay, my topic today is 6G as a terabps information highway for on-device AI services. 6G will not be, focused on just one service or one application. It will be used for many different scenarios and applications. But today, I especially, focus on very interesting items, which is on-device AI. I will skip my abstraction. 6G will be used for the many different applications. Those are several, items which I pick up today. The first one is hologram AR. We already have many XR device and service, but hologram AR will require much more data rate, much more performance. And it should have, the AI capability. So on-device AI will be included this AR device. So this will be unified with high-throughput communication and very intelligent AI processing. So this is something new and will require much higher or much better KPIs compared to the 5G service. The next one is drone taxi. We already know that there are many trials for the autonomous vehicles. The vehicles are driving on the earth, on the road. But drones, will be flying on the sky. So the drone will require much more complicated controlling technology. And will also, receive many information from the air. The image information, sensor information, also some interaction with the other drones. Yeah, so the complexity which will be much more higher. So we think drone control, it could be possible in 5G time, but more complicated and much more advanced control could be done at the 6G time. Also, drone will be more popularized in 6G time. From 2030, some people will take a drone as a taxi to go to his home or to go to his office. Also, at the same time, ambulance, which is very important for the urgent case. So in that case, people will use drone, then he will quickly go to the hospital. It is very convenient and very useful for us. So drone taxi will be one of the major applications in 6G time. So which will also at the same time requires much advanced KPIs can be achieved by 5G communications. So we think this drone and drone mobility will be the one of the key area. And this will be, totally important things for the AI applications. We assume that the on-device AI chip will be included in drone. So the part of their controls can be done by himself. So it will be operated by himself using the AI inside the device. But in sometimes, in urgent case or some collaboration case, we need some further AI processing techniques. So not just on-device AI capability, but also some kind of communication capability is required to utilize drones furthermore. And then we think there is another very important application, which is related to medical service. Currently, we have many diseases, even virus is very serious now. So this is just the starting point, I think. We will have much more problem in our health. And also, our society will be, will have a big difficulty because of health problems, virus problems, many kind of medical problems. To overcome those kind of limitation or important problems, we think the 6G can help us. So 6G medical healthcare device or sensors will be included in our body. It will be attached on the body, or sometimes some organs will be enhanced or fixed using some kind of the implant devices. So these kind of medical applications are widely used in 6G time. I mean, not only in the hospital, but also in the any area, which will be connected to the hospitals. So some very important signal from the body to transmit it to the server. Server means the hospital or some medical centers. So you will be cared every time, everywhere. And I don't know exactly, but some kind of actuation could be included in this device. So only very urgent case, some kind of actuation could be done in this server, in this in this sensor. So you will be the quickly cured. Yeah. So some kind of actuation and the sensors will be combined together in the 2030 60 period. So the healthcare could be very important example for the 6G area. And in order to do that, in order to do some actions or some signaling very, very regularly, or some kind of, depending on the situation or depending on the person, we think the AI chip will be a very important role for this device as well. So those three examples may rely on-device AI capability a lot. But I will let you know in the next slide, but this on-device AI has also some limitation. This limitation can be overcome by communication technology. I will explain further in the next slide. Now, as you can enjoy in your phone, your voice can be recognized by your phone. But interestingly, your voice not recognized by your phone directly. Your voice will be transmitted to the server. Server is far from you, and then server will recognize your voice, and then the response will feed back to your mobile. So the actual AI processing is done at the server, not in your phone. So what is the problem? If you do it sometimes, or only a few people can do that, then it is okay. We don't have any problem. But many users or many more devices use AI service or AI functionality, then the communication bottleneck can be included. What is the bottleneck? One of the bottleneck is latency, because the distance is far from your device to your server. It's very far, right? So the latency would be a problem. Also reliability. Wireless channel is not stable any longer. It could be sometimes very good, and also sometimes it is very poor. So the wireless situation is changing all the time. For example, when you are driving, your car will be, the very bad situation for the communication link. So the wireless link should be guaranteed to provide a good reliability, as always. So this is the big limitation of current cloud-based AI service. So we think on-device AI solution could solve those kind of hurdles. So on-device AI, I mean that your AI chip on your phone So there is no latency any longer, right? The phone will be directly respond to you, directly recognize your voice, and directly recognize the image or videos directly. So no latency is included. Also, the reliability, we don't need to worry about reliability because it will be done at your device. So reliability is guaranteed already. So I think the on-device AI will be very much beneficial and will be widely used in 5G time. But once the AI requirement is increased and also many users want to use on-device AI for many different purposes, in that case, this solution will have also some challenges. One of the challenges is computational capability. The AI chip on device is good, but must be much lower capability than AI chip on the server. On the server, we can use bigger or the higher performance AI chip, and even we can parallelize AI, solutions. But on your device, even if it is your car, your AI chip capability will not be very high. So the computational capability is a big challenge in this case. Also, the data. The device can collect data. Yeah, it is possible. So it will be helpful to improve your AI performance. But just one device can collect, I think, very small data. So this small data will not be highly useful improving AI performance. So I think we need more advanced learning techniques is needed because in order to avoid this data shortage, small data problems. Also, the data security is also an important problem. Server can collect data from the mobile, so they can improve or increase the number of data and the size of data. But in that case, security will be very important problem, and this is related to the privacy. So Europe already started to do some kind of control in the data privacy. They started to consider data privacy as a law, so which is GDPR. So data security is also important, even if you can improve if you can have many data at your hand. So we need to have some kind of learning solution which increase data, but enhance the privacy problems. So those kind of things can be done by, I think, connected on-device AI solutions, not the standalone solution, but connected on-device AI solution can solve these problems. And this connection between the device, AI devices, can be prepared by the 6G standard. So one of very big challenge and one of very big opportunity for 6G is the on-device AI communication, and which is can be called as connected on-device AI. I will let you know what kind of technologies can be used in connected AI solution. Generally, there are two solutions. One of them is split AI or split inference, or somebody can call it as split computing. Because as I said, the AI capability or AI chip capability on your device will be limited, even if it is a big size device like your car or your drone, but that is still limited. So your capability, your computing capability is limited on your device. So I think in order to improve your computing capability, you can split your computing between your device and server. Some urgent computing can be done by your device, but highly important but not urgent tasks can be done at the server. Or if the latency is low, you can do it collaboratively. I mean, part of your computation can be done at your device, and another part of your AI computation can be done at your server. And also, there are two kinds of servers, interestingly. The server from the internet service provider. Also, the server from the the service companies. So the splitting can be done between the different two server providers. So there are, basically 3 pointers: your device, your edge server, and your cloud servers. So the well organization, well splitting will be very much beneficial to improve your computing capability. At the same time, you can reduce your energy consumption in your phone. So this is split computing. And another one is the federated learning. Federated learning will be also important. Federated learning can be run by your data, but privacy will be still preserved, because you don't send your data directly, but your AI model will be shared to the server. So you don't worry about your privacy any longer once federated learning technology is used. But here, the user should send their model to the server, and the model exchange are, iteratively processed. So the high throughput is required in order to apply this federated learning for the on-device AI systems. High throughput, one of big agenda for the wireless communication. Yeah, maybe in the 6G as well. So I will explain which one of the item and the related communication technologies in the next slides. This is the deployment scenario for the split inference. As I said before, the splitting can be done between your device and your server. Some of computation, computed at your device, and the other computation can be done at your server, whether it is edge or cloud. Maybe cloud, right? This is one of the good example. And secondly, you can assume that there are two servers, as I told you. There are cloud server by internet provider, and also you have an edge server by your network provider. So the computation can be shared between the edge server and the cloud servers. So this will be very helpful to improve your computing capability once the latency is okay between the mobile device and your edge servers. And also, if there is an urgent task and also some latency limited is happened, then you can compute some part of your neural network processing at your mobile device. So the computation can be shared among your device and your edge device and your server side, the cloud server side. So this is the deployment scenarios of split inference. However, here, as you can see here, in order to split your computing, the communication link should be highly reliable and should be also at the same time, should have also very small latency, almost zero latency. So the latency and the high reliability will be much more important than current situation. Yeah, currently, the whole computing performed at the server, or in 5G times, whole computing can be done at your phone. But this communication will be a part of in between the whole computations. So this the communication link should be well designed. The low latency, much low latency, and much higher reliability is required. So the solution here is just one solution, not the perfect solution yet. This is one of the example. Currently, we design communication link by the, very important and very popular techniques, divide and conquer. So your each functionality in modem are separated optimized. Because of this separation optimized, the trade-off between the performance and the latency cannot be well optimized. It is convenient to optimize the communication link separately. This is coding area, this is source area, this is application area. It is good, not bad, but the optimization would be highly limited. So the neural networks can be replaced in those parts. Neural networks can be optimized by one, objective. And that time, the latency and reliability can be, easily optimized compared to the current solutions. I don't know. This is a futuristic technology, but we expect that this can be a great role in 6G communication time. And we will use this technology for the wireless communication, not wired solution. So the adaptivity is important. As I said, the wireless link is always, the changing, varying. So the link adaptivity is important. So here we can use some link adaptivity technique for this traditional or the general AI-based communication technique, which is called as autoencoder transceiver. So adaptive autoencoder transceiver can be used to solve latency problem because it can optimize end-to-end approach. So this is one of example. Secondly, advanced multi-antenna techniques, which is communication technique, not AI techniques. But by enhancing communication techniques, we can improve reliability. As you know, point-to-point MIMO can improve link quality. So it can be used for the improving link quality. And also multi-user MIMO. Multi-user MIMO can use multiple antenna for different devices as the receive side. So the link throughput is preserved, but the system throughput can be improved. So we can use this multi-user MIMO as well. And for further improvement, we can use massive MIMO. Massive MIMO is similar to the point-to-point MIMO or the multi-user MIMO, except that it can have, the baseline have so many antennas. So in a 6G, we can use many more antennas or many other further advanced antenna technologies. We can improve, link quality or the reliability. So this could be one solution. The second cooperative AI technique, which is learning-related one, which is federated learning. Federated learning is similar to the, the distributed learning technique, except that it can enhance privacy. Because in general, distributed learning, the data, the real data, your data will be shared or your data will be feedback to the server. In that case, privacy will be hurted a lot. So the federated learning send not your data, but your model, local model, and collect that model to the server, and this will improve your learning performance. So one of the solution to improve this federated learning is the compression techniques. You can compress your model data, then you can improve the learning capability with the small data. So model compression techniques would be one of the very useful techniques to improve your federated learning. And also for the radio communication technology, yeah, because uplink is will be very busy in federated learning because you should transmit, you should feed back to your local model to the server, and server will be exchangingly, iteratively sent back to the users. So many users will transmit their the data to the server. So the high throughput is highly required. Current, millimeter wave may not be enough. As based on our calculations, almost TeraHz are required for better, learning. So I think this high throughput transmission technique based on TeraHz would be very important. This is my conclusion. 6G will be provide a very big beneficial for everybody. So, but in order to do that, we need connected AI techniques, especially when on-device AI solutions are used for many 6G applications. Thank you very much.
Thank you, Dr. Kim, for giving us a high-level view regarding application service in 6G. And I remember that Dr. Kim was an expert in communications, but I found that he's now an expert in AI as well. So I expect his great contribution to this industry. So through this session 2, Industrial 6G Strategy and Prospect, we heard views from global industry leaders. And through this session, we found that 6G is not just a dream far away, but just a feasible future nearby. So once again, thank you for 5 speakers from the global industries, as well as audience in online. So thank you again. And after a short break, we will convene next session on vision, followed by a panel discussion. So we'll have a break until 2:50 and reconvene at 2:50. Stay connected and expect lucky drawing sometime in the afternoon session. Thank you.